This notes page is on solving systems of nonlinear equations. Now we did this in Unit 1 where we just looked at a graph. And if you have a circle and a line, the solutions to the system are the intersections. And you might have more than one. Well, this time we're going to use algebra to solve the system. So before we get going, I just want to remind you that you have different types of equations. They're nonlinear systems. So one that you might see is x squared plus y squared equals r squared. This, when you have a x and y squared, that's the equation of a circle. And for example, x squared plus y squared equals 16. This 16 is r squared. So the radius of this circle would be 4. And to graph equation of a circle, the center, there's no translation, so it's 0, 0. And then the radius is 4, so you go out to the right 4, up 4, left 4, down 4, and then you just do the best circle you can draw. Okay, so that might be helpful because I want you to visualize before you do anything what you've got here. So for example, if you wanted to solve this system, it's a nonlinear system. This is not a line, it's a circle, and this is a line. So if we want to solve for x and y, we've still got 3 methods: substitution, elimination, and graphing. If we want to use the substitution method, you want to use the same principle as I taught you before, and that is look for a variable that has a 1y. You would definitely not want to use substitution for this x, solve for this x, because then you'd have the square root or this y, so that's out. But in 3x you wouldn't want to solve for x because you'll get a fraction. So I'm going to solve this one for y. I'm going to move this minus y over here and this 10 over there. So that would be 3x minus 10 equals y. Alright, so once you have that, then you're going to, same principle, if you solve for y in equation 2, you're going to substitute in for y in equation 1. So that would be x squared plus, and I've been getting you to use the parentheses substitution method all year. So when we substitute in 3x minus 10 for y, you have to realize it's those two terms are being squared, and so you don't distribute the 2. Nope. This is a binomial squared again. So we're going to square double square. So this means 3x minus 10 times 3x minus 10. And you can FOIL it out the long way, or you can use my little shortcut, which is square the 3x, which would be 9x squared. Multiply those two together, which would be negative 30x, and double it, which would be negative 60x. Square the negative 10, which would be positive 100. Alright, add like terms, you get 10x squared minus 60x, and these 100s will cancel since they're on opposite sides. So now we want to solve this by factoring, and it doesn't have a constant at the end, so we can pull out a GCF of 10x. That's another way to factor. It's a perfectly fine way to factor, and you get 10x times x minus 6 equal to 0. So then you set each factor equal to 0, and you get x is 0 or x is 6. So this is where it gets a little different. You have to be really organized because there are 2 x coordinates and they don't have anything to do with each other, and you need to find the y coordinate partner for each one. So with the substitution method, it's always going to be this solve for equation over here that's going to be useful. So for this x equals 0, y equals 3 times 0 minus 10, and you get y is negative 10. So one of the answers is 0, negative 10. And for this x equals 6, y equals 3 times 6 minus 10, so y is equal to 8. So the other answer is 6, 8. And I drew the picture here. I went ahead and showed you the graph so you aren't confused as to how there could be 2 solutions. Well, it's because this is a non-linear system. It's a circle intersecting a line, and so that line goes through that circle in two places, so algebraically it confirms that. So sometimes you might have 0 solutions, you might have 1 solution, you might have 2 solutions. It's even possible to have 3 solutions. Alright, let's look at another one, and this time we're going to use the elimination method. So I would not want to use the substitution method here anyway, because there's nothing really good to solve for without getting a lot of fractions. So the principle is the same. You want to try to eliminate either the x squareds or eliminate the y's. And you can eliminate whichever one you want. So if I eliminate the x's, I'm going to multiply the target number, the number that you want to make 3 and 5 become is 15. So I'm going to multiply this top equation by 5, and this bottom equation I want opposites, so I want a negative 15, so I'm going to multiply by negative 3. So the first equation would be 15x squared plus 10y is equal to 26 times 5 is, let's get rid of that, 130. And the bottom equation would be negative 15x squared plus negative 21y equals a negative 9. So if I add, these go to 0, and then 10 minus 21 is negative 11y, and then 130 minus 9 is 121. And if you divide by negative 11, you get y is equal to negative 11. Okay. That is the part of an ordered pair. So you have to go find x. And so if I take the bottom equation, since the numbers are just a little smaller, I now know y is negative 11. So watch what will happen. 5x squared plus 7 times negative 11 equals 3. 5x squared minus 77 equals 3. 5x squared equals 80. Divide by 5. And you get x squared equals 16. How do you solve for x again? Yeah, to get rid of the x squared, you take the square root, and when you take the square root, it's plus or minus. Okay, so we're not done yet. You have to go further. You have to write the answer in order pairs, so you have to understand what this means. So what this means is that x might be 4 or negative 4 when y is negative 11. And you have to write it out. You can't just let me guess that, and just guess that you understand. You have to write the ordered pairs. So that is where it gets a little tricky for students. You have to remember when you take the square roots, plus or minus. So the reason this happened, this graph hopefully will help you. This is a quadratic, so it's a parabola, and it opens upside down, and this is a parabola that opens upside down. And so you can see the intersection happens at 4, negative 11, and at negative 4, negative 11, and the algebra kind of confirms that. Alright, I would pause the tape and try this one and then come back and see if you did it. You can use whatever method you want, or can you? Okay, I'm going to use substitution to start. I'm going to solve for this y right here, so that means I'm going to move this minus y over here and this negative 1 over there. So 2x plus 1 equals y. Okay, now definitely want to use the parentheses substitution method, because this minus is going to cause a lot of problems if you don't. So I'm going to substitute in for y, and I have to distribute that negative to both terms. And then look what you get. You get a quadratic, so you have to set it equal to 0 and factor it. And then x is 3 or x is negative 1. So there it is. You have two completely separate x coordinates, and I like to draw a little line in between them just to make my brain know that they aren't related to each other. I need to find y when x is 3, and I'll use that. So one ordered pair is 3, 7. And I need to find y when x is negative 1. and y is negative 2. So the other order pair is negative 1, negative 1. The answer is not 3, negative 1. That's not it. The answer is the order pairs 3, 7, and negative 1, negative 1. Now you could have used elimination if you wanted to, so I'll show you that. And the reason I want to show you that is because I don't want you to make mistakes. So you could eliminate these y's if you multiply this bottom equation by negative 1, which means all the signs change. And that does give you 0, but right here I want you to concentrate. These are not like terms. So x squared minus 2x. You can't add them or subtract them, but you can just write them. X squared minus 2x. They're not like terms. Equals 3. So now you have quadratic and you can set that equal to 0, and it factors into the same factors it factored into in the other example, and you get x is 3 and x is negative 1, and then you plug that in. So we'll pick the bottom one, negative 2 times 3 plus y equals 1. That gives you y is 7, and negative 2 times negative 1 plus y equals 1, that gives you y equals negative 1. So you get the same answer, but I just wanted to show you that you can't, these are not like terms, so you can't add them together, but you can write x squared and then the minus 2x equals 3, and then you've got the same type of problem. Okay, so there are some practice problems in the lab manual there. Make sure you practice these and check the key, and make sure you remember when you take the square root it's plus or minus, and separate it out like this so that you don't get confused. And you also can check your work with Desmos. That actually kind of helps you start to understand the concept if you kind of look at what the solutions are.